So this is the simple example first for milling. Okay, so actually the operation that we learn, including milling, drilling, and also lathe. But for lathe only we have simple example in the chapter 5, but our focus more on milling and drilling process. And for milling, actually, as I told you before, either for when you, the first thing you need to do when you use the simulator, you need to define the workpiece dimensions. I mean the X, how it is the length, what is the width, and what is the thickness. After that, you need to decide about the tool that you are going to use. Is it tool for milling? Is it tool for drilling? Or the tool is used for the lathe or for turning? Okay. The figure that I'm going to provide for the quiz here, you are going to draw it. I mean, imagine that the figure that I gave you, it consists from two rectangular, for example, one outside rectangular, one inside rectangular. So in this case, I mean the workpiece or the original workpiece, it was just the workpiece which consists from the dimension here that I defined, like x20. I mean the workpiece that I defined here in the settings. So I use this workpiece here, for example, 200, 230. So the dimension is 200 for X, 200 for Y, and also for the thickness is 30 for Z here. So it depends on what is the requirement in the question. So you need to define your workpiece here. And the second is the tool that you are going to use. So if you are going to use the milling tool, so you need to select milling tool. If you are going to use lathe tool or turning tools, you need to define these tools. So in our case here, for example, we are using milling tools, and we need to define also the diameter and also the, wait. For example, the workpiece or the original workpiece with its dimension defined, then this represents what is the drawing that we need to mill, for example. So after you define the workpiece, you define also the tool that you are going to use. For example, here we are going to use tool number 1. Then what is the, or the where is the coordinates, or where I should place the workpiece. For example, I need to define the coordinate for the workpiece here. I mean like the original for place, or the point of origin for the workpiece. This is the point of origin for the machine is 0, 0, and here I'm defining the workpiece origin. I place it, for example, 2020. I can place it also 0, 0. It's okay. But when, in the place that you are going to place, you need also to consider during your writing for the coordinates. Then I define the, I mean the tool that you are going to use. Actually, as you can see here, the shape is all lines. So we are going to use linear profiling here, no circular profiling, and also no drill. So we need just to define the coordinates. So all we are going to use G01 here. So you can see G00 for the fast traverse, and also for G01 for the linear. So when we are going to run this one, so this is the original workpiece. I try to duplicate the, I mean the hair, just to make like 2 round, to make it more smooth. Then it will move to the second place to create the second rectangle or square inside. So this is for the linear profiling. So if you want to create any type of linear profiling, so you need to define the coordinates, and you need to define the line or the path for the tool to go through in order to create. You can change the dimension here. When you change the dimension, I mean the coordinates, you are going to change the path for this tool to make the milling for the machines. Another example here. Is for 201. If you want to have for drilling, for example, or this one with 01 and 02. In this case, you are going to use the, the linear profiling and also the circular profiling, which is clockwise circular profiling. As I told you before, any code you have here, you can just put the mouse on it. It will show you what this code is used for or why we need to use this code here. So the same here, we use part number 2, define the place for the bar, then define the original points here. Then what is the tool that we are going to use? For example, here, tool number 1, also the same for milling. Then here we have to define the model code that we are going to use. Is it since we are going to use the for circular profiling, that means should have some of the round on the corner for square, for example. If we run this one, so we have, you can see the dimension of the workpiece here is smaller. As you can see here, it's create the linear profile until the corner here, then it has circular profile, then linear profile, again circular profile, then linear profile, circular profile, linear profile, circular profile. So in this case, you can use the G02 in order to create a circular profile. When we are in clockwise direction, that means in all this we are clockwise, clockwise, clockwise. So we use G02. If you are counterclockwise, so you are going to replace this one with G03. So in this case, we need for the G02 or G03, we need to define the coordinates for the, the destination or the end point of the workpiece. The arc. In addition to the place of the center of the arc with respect to the x-axis, we call it I, and with respect to the y-axis, we call it 0. So in this case, you need to define the value you can see here, I15, J0 for the first arc. Then you have I0, J negative 15 for the second arc, I negative 15, J negative J0 for the third arc, and also I0, J15 for the fourth arc. The distance from the center of the arc to the x-axis or to the y-axis, we define here the coordinate for these values. So in this case, we can create the circular arc. You can have one arc, you can have 2, 3, depends on what's the requirement in the figures to have arc in your milling process. Another example here is for the drilling, for example. So we already have the drilling, and we said for the drilling, we have a different can cycle for drilling. We can use G81, we can use G82 and G83, depends on what is the requirement for the, what's the parameter that we are going to use to create the hole or to make the drill operate, and also what is the requirement for the size for the drill, the length of the drill, and so on. So in this case, we create that we can create the holes in the workpiece. So the same as usual, you need first to define your workpiece and the place of your workpiece here. Then you need to define what is the point of origin. That means define the point of origin for the workpiece itself with respect to the origin of the machine. So if we can see here, we use the G81, which is the canned drill cycle here. And as we said before, for the canned cycle here, or G81 will be used to create multiple holes or perform multiple drill operation. Just we need to perform, no need to define anything. We need to define only the depth of the hole, and then what is the standby position on the top of the of the workpiece. Then we need to define the coordinates or the different coordinates for the hole places. So if we run this machine, actually you can, as you can see here, we use tool number 2. I already defined the tool number 2 is for drilling, for example. So you are going to use, if you do not have any tool, so you just define or create your own tool from this place. So you are going to add tool here, add, then you define the parameter for the tools. So is it flat for milling or pull also for milling, or you can want point it for drilling. So you need to define the diameter and you need to define the length of the tool and also the angle here for the sharpening between the drill pitch here. So if we run this code, for example, we have this workpiece here. We create multiple holes by using the G81 cycle here. And the depth for each hole is -15. You should know that, I mean, if you want to make a complete hole, that means to the other side of the workpiece, the depth of this hole should equal to the workpiece thickness. I mean, if I said the workpiece thickness is 20 here and the depth of the hole is -15, that means it will reach to not to the other side. It will still close hole here. But if you want it to be open, so you need to have like, if the thickness is 20, so it should be like -20. If you want it 30, so it should be like -30 and so on. So here how to create multiple holes by using the G81 drill. And also for the G82 and AJ83, it will be the same, but you need to define multiple parameters here related to the, I mean, like for in the case of the big drill, or in the case of the uh, you like parameter like Q, like IGK, and so on. So, but in the case of the usually for if you want to do multiple or you want the drill to go to make a deeper hole. So in that case, you are going to use such G83 or G82. I mean G83, because you are going to define. It will make the hole in stage. So the drill will go down for one stage, then it will go deeper for the second stage, the third stage, and so on. The different also will be in the defining the, I mean, the parameter that you are going to use. For example, in the case of G83, you need to define more parameter here. For in addition to the coordinate, you need to define, for example, the big size here. In the this is in the case for 83 with the Q. If you 83 with IJK, so you are going to define IJK and so on. But at the end, it will be, I mean, it will perform the same, because if we have the smaller, I mean, depends on what is the uh, depth of the hole that is required. This is for the definition for IJK. So you need to define what is the K, the first stage, the second stage, and the third stage depth. So when the machine is, or the drill is used to make a drill with the more than one stage, so it can be used the G83 with this touch stage. Like it's go for the first stage, but because here I mean the thickness of the wick, the the workpiece is small. It's not that we do not need that the deeper, because the maximum is can go for 30 millimeter only. In all case, just we need to define one model code with its parameter or its required parameter. Then others all will be like coordinates here. But you should define this coordinate correctly based on the given coordinates. I mean, where is the center for this one, or this workpiece will place where in each area? I mean, what's the diameter of this workpiece, of this hole, and so on. So this all be depends on the size of the tool that you are going to use. So as you can see last time also for this one, for example that we have in the chapter 5, I mean, we have example here in which it has like linear profiling, but this linear profiling to create like rectangular, but at the end of this rectangular is go back to it's like two rectangular, but they combine to with each other. So as I told you in the beginning, you need to define what your workpiece here, and you need to define the coordinate for workpiece. Then you need to use the, since we are going to use linear profiling, so it's rectangular, so no need to have any other type of the code. So just D01, which will be applicable here. So as you can see here, even the coordinates is not the same, but the shape is the same. As I told you, some of the coordinates in the example that we have in the slide is more applicable to real machines. So if you try to use the code directly, so you cannot generate the exact shape here. But what you need to do, you need to redefine the workpiece dimension here, and also the size or the coordinate for your shape based on the given drawings, for example. The same is with example number 2 also. Example number 2 also use the same, linear profiling. So you can see for linear profiling in example number 2, chapter 5, is the same. When you duplicate the loop, you need to repeat that again. So just to make it smoother shape, but it's not compressed, so you can use it also for one time. I mean, this is the shape that we have in the example number 5, even with different dimension, but overall the shape is the same. So for the quiz, when I ask you to do the shape, try to select the workpiece which is bigger than the shape that you will be given. Then you need to create your drawing inside this workpiece. I mean, you create the milling inside the workpiece, you create the hole or drill inside this workpiece, and so on. So I mean, imagine that this one like the background of your drawing. I mean, it's not compulsory to use the same or the exact dimension, because for the workpiece can be like rectangular, so you need to define workpiece it's a little bit bigger than the, or it can be much bigger. I mean, but at least don't go to the out limits of the allowable machine workpiece. So sometimes if you enter some dimension which is bigger, so it show you alarm here, it will say or tell you that this dimension is out of the limit in x-axis, out of the limit in y-axis, out of the limit in z-axis, and so on. So in this case, you need to reconsider the dimensions that you enter for your drawings. So at the end, for example, at the end of your, after you write this code, for example, you write it, you just try to run. If it's generate the shape that is required, so you just screenshot for this one. Try to make it like close to the figure or more clear to see that this is the figure that is required to do it. Sometimes you can do only milling alone. Sometimes you can make the milling with drilling together. So it depends on what you like. For this one, for the example here, the one that we have in the tutorial previously that I show you, which it has drill and also it has milling at the same time. What you need to do, only you need to convert, to change the tool. So the first tool for milling, so you select the tool for milling. If it's T1 or T2 or T3, depends on what is the tool number in your tool. It's like your tool that you have on, you already enter here in the settings. So if it's tool number one, tool number two, tool number three, depends on what's the type of the tool, what is the name of the tool, and so on. So if the tool is used for milling, so it's for milling. It's used for drilling, so use it for drilling. So this is the original example that we have before. You may require to do the similar things with different dimensions. So you can play with these parameters. I mean, this only one meaning, for example, one linear. This include all operation. It has linear profiling, it has circular profiling, and it has drill. So you can use any of these operation in your, I mean, either in the example, in the quiz, or when you try to practice for using simulator. Any question until here? Here the operation, I mean, you need to define here as 2000, for example, or S 1500 and so on. But also in the controller here, if you want it to go small, I mean slower, to see how the operation is run, just go for this one. You can adjust from here. This is only for to show, but the real speed for working for the spindle here, the speed of the spindle, you need to change in the code that you have. Then try to change. Sometimes you place the workpiece in the wrong places. Sometimes you select wrong dimensions. Sometimes you select wrong parameters in the code. So anytime you got the alarm, try to adopt or try to change the values that you have here. For the code, for the quiz, you are required to create the correct dimension for the workpiece. I mean, for not the, for the workpiece, for the drawing or for the figure that you are going to be provided. I mean, if I said the hole is at x equal to 5, y equal to 10, it should be there. It should be at the same coordinates. If I said this length of the line, or I mean, the length here is 20, so it should be 20. The length here is 30, so it should be 30. The type of machine, this, as we said before, this you can select the type of machine. Is it for milling, for turning, for cutting, whatever? So our work more on the milling machine, so you just select milling and milling center. If you want to work for turning, you need to select for turning center. So you just go for, I mean, for the lathe or this one. So you just select the turning. So select the turning center. So if you want to open this program, the one that we have for the turning or for the lathe, so you just run. As I told you before, there are many demos there, there are many tutorials. You just practice to learn more about this one, because this will be helpful for you for your lab next sem if you register for the lab course. Maybe if you still the situation the same online and so on, so you will need such simulator to work with for your lab next sem.